Hello and welcome to this lesson over experimental and theoretical probability. Before we can talk about what experimental and theoretical probability are, first we have to discuss what is probability itself. Well, probability is just a numerical value from 0 to 1 that measures the likelihood of an event to occur. So it's a numerical value between 0 and 1 that measures the likelihood of an event to occur. And we can display this on this number line here. So we have 0 here on the left-hand side and 1 here on the right-hand side. And we see that at 50% chance, or 1/2, is equal to 0.5, this would be equally likely to occur. Or not occur. And then over here at 0, it is impossible for it to occur. And over here at 1, it is certain to occur. Now, what does this mean? Well, it means that if you have 0% probability or you have no probability of an event to occur, then the probability is that the event will not occur. So if you have 0 probability, then the event will never occur. And if the probability is exactly 1, then it will always occur. Now, there are a couple of different ways that we can write probability. One is by a fraction. We can also write it as a decimal, or we can write it as a percent. Now, what does this look like? Well, if I say have 5 cards, and 2 of them are hearts, and 3 of them are spades, then the probability of me drawing a heart is going to be 2 out of 5. Now, if I want to convert 2 out of 5 into a decimal, I just divide the numerator by the denominator. And I get 0.40. And then if I want to convert this to a percent, I'm going to move decimal 2 places to the right. And so this would end up being 40%. So let's look at an example. All right, so looking at this example, we're going to start with a fraction, 7 out of 12, and I want to convert this to a decimal. Now, I can do this the long way, where I do long division, and if I do that, I'm going to end up with a repeating number. So let's just look at what that would look like. So I've got 7, and I'm dividing it by 12. So I would add a 0.0 here, and then 12 goes into 70. That's going to be 5 times. Then we subtract 5 times 12, that's going to be 60, so that leaves us with 10. 12 doesn't go into 10, so we have to repeat this process. So far, we're at 0.5, and 12 dividing 100, that's going to be 8, and we subtract 96, and what that gives us is 4, and then 12 will divide 40, because I have to add another 0. 12 will go into 40 3 times. And then this will actually just continue to repeat. So we can convert this to 0.583 repeating. You can also just use a calculator for that. Or if I want to get a percent, then I'll say 0.583 repeating and just move the decimal 2 places. So this becomes 58.3 repeating percent. Or if we want to round this, it becomes 58%. So let's talk about the different types of probability. We have experimental probability, which is based on an actual result, saying that you actually flipped a coin or actually drew a card or you actually rolled a die. So experimental probability is based on an actual event. And its results. This can be things like flipping a coin, or drawing a card. Then we have theoretical probability, which is a little bit different. So whereas experimental probability is where we're actually conducting the event, theoretical probability is just what we think the probability should be, right? So when you roll a die, you think that every single outcome should be exactly the same. That's where the theoretical probability comes in. That's you looking at the die saying, oh, well, it has 6 faces, and you assume that the faces have an equal possibility of occurring, face up. Now, that may not always be true, right? You have a loaded die, and that's where experimental probability can help us. You can actually see whether or not a die or a coin is loaded by running that simulation several hundred times and seeing what the probability distribution actually is. So the theoretical probability is the ratio of favorable outcomes to the number of total outcomes. And this is that perfect world that we talk about. It doesn't always occur, but when it does, it's very nice for us. All right, so let's look at an example of the difference between theoretical and experimental probability. All right, so in a perfect world, if you flip a coin 10 times, it should land on heads 5 times. So if we want to write the probability, it would look like this. We would say probability of heads, so we write probability and then our event is equal to, well, you assume that a coin is going to land on heads 1/2 of the time. So if I run 10 trials and I want heads, I'm going to have 5 over 10. So you see how we just increased the ratio, right? We made sure that our total number of outcomes was 10 and that our favorable outcomes reflected half of that. So let's say that we actually ran this trial. And instead of getting exactly that distribution, we have a head, a tail, a head, a tail, a tail, a tail, a head, a tail, and a tail. So here, if I'm looking for the probability that I had a head out of this trial, it's actually a little bit different. It's actually 4 out of 10. So it's slightly below our theoretical probability. So theoretical probability is something, it's kind of a target that we use, but it's not necessarily always going to be accurate. So that's the difference between theoretical and experimental probability. Now for our last example, we need to talk about something called not. All right, so if we're talking about the probability of a complement, that's what we're saying not. So the complement is all of the probability which is not what you were originally looking for. So if we're looking at a jar and it contains 10 red marbles, 8 green marbles, and 2 blue marbles, and I want to find the probability that I do not have a green marble. So all I care, I don't like the color green. I just don't want green. I only want red or blue. So the probability of this occurring is going to be 1 minus the probability of green. So if I don't want a green marble, the probability that I don't draw a green marble is just the opposite of me drawing a green marble. So 1 is the total probability, so that's our total, and we're subtracting the probability of green from that total. So I would just say 1 minus, and there are 20 marbles in the jar, and 8 of them are green, so 1 minus 8 over 20. So we want to change this into a fraction to be able to do this this arithmetic here, and we see that it's 20 over 20 minus 8 over 20, and the probability not green is going to be 12 over 20. So that's all that we need to know about probability for today. Here's our agenda, is that we're going to complete our reflection, which you'll get from Mr. Fox, and then you'll also work on your Monday homework. So that's our goal to finish by the end of the day, is complete your reflection and to finish your Monday homework. All right, have a wonderful day.